Hello there, 11th graders. This is teacher Krishna, and welcome to our physics class for week number 13. One more time, thank you a lot for all of the effort you have done so far into completing your exercises and, of course, attending the online lessons. Keep it up, please. Before we start, we're going to follow some general directions, log into Agilex, enter the Google Classroom, download your Word document to create your summary, and of course, name it as it is specified right at the bottom. As we move, remember to take notes on the Word document so you can keep track of the most important information from this PowerPoint presentation. Just like always, it's always good to start with our end in mind. For this week, it's the following. Understand, analyze, and apply general concepts about the simple harmonic motion in representative real models. All right, let's continue up. So, and we're going to talk about a simple harmonic motion. This is a very interesting topic to learn about, and of course, it's very applicable. So, you're going to be doing a small project today. So, first of all, we're going to learn some general basis about it, and then we're going to move up with the project, okay? So, first of all, the back and forth motion of a swinging pendulum is an example of a harmonic motion. It's very important, the word pendulum in here, because that's what we're going to focus on the project later on. So oscillatory of repeating motion. Those are other two ways in which you can actually call harmonic motion. And this is something very interesting. You will find the word bob in several harmonic motion or pendulum models. And just for you not to get confused, let's have this concept very clear. So bob is basically the object at the end of the pendulum. That is a very curious fact that you have to take into account. And here is something very important on how to measure the length of your pendulum. So, and some students might think that you are going to measure the pendulum's length from the point of attachment to where the bob starts. But in reality, the real length of the pendulum is measured from the point of attachment to the center of the bob. Please do not forget that, because that is going to be very important later on. So we're going to have a very small exercise. Please go to page number 1 on your topic, read and analyze the steps taken in the C in the action section. So it's important that you click on the section of check your answers. Originally, that was a project that you had to do at home, but if we had done this project and the following project that you're going to do today, that will be just way too much for you to do today. So just read and analyze all of the questions as well as the answers that you have right there. Once you're done, please come back. Okay, so welcome back. Now I'm going to give you a general summary on what the questions and answers try to convey. First of all, the swing of a pendulum is completed when it goes forth, back, and it returns to its original position. Oh, this is called, I'm sorry, there should be a D, the period of the pendulum. This will be very important for you to take into account, because later on you will be asked to measure several periods of your pendulum. So notice it has to go, the pendulum has to go forth, back, and come back to its original position. Okay, mass does not affect the period of the pendulum, and this is something very interesting, because some students might think that if the bob has a higher mass, then the period in the pendulum will be higher or lower, which in reality is not in that way. So mass does not affect. Have that clear at first. The amplitude is the distance between the resting position of the pendulum and how much it has moved to one of the sides. The amplitude affects the period, but just a little bit. So we're going to jump a little bit to the picture that we have right here. So you can notice that there we have the amplitude, and as students think that the oscillation of the pendulum might be affected if you place it at a higher or at a lower distance. When in reality, one more time, amplitude affects it, but just a little bit. It's not one of the main things that affects the period. Let's continue. We have that the length is it's the only factor that affects greatly the period of the pendulum. So one more time, we have to remember that length is what we measure from the attaching point to the middle of the bob. So this is the only thing that actually affects greatly the period of the pendulum. So if it is higher, it is going to have a higher amplitude, of course, as well as a higher momentum. But if it has a very short length, then the period of the pendulum will be lower as well. And lastly, something that you need to take into account is a very small equation that you need to use in order to find the period of a pendulum. And just like it is specified in the image, the period is time, or most likely period, equals 2p and multiplied by square root of the length divided by gravity. You can write it down somewhere so you can take it into account. Right, so this was a pretty short topic, and even though it is a pretty simple topic to learn about, the applications that we can have are great. So that's why your evaluation will be mainly the application of the principles that you have studied so far. So for your evaluation, please read and summarize topic 6.01. It's a pretty short topic, but anyways, it's always good that you go to the platform in Agilex and you can take a look at all of the content that there is. Go to page 2 and complete the lab report. And you will find that there you have 2 ways of completing the lab. So you have to use the manual lab simulation to complete the lab report, because I want you to create this in your house. That is why we're having a pretty short class right now. That's why you will have more time to complete everything, okay? And please include pictures of your project in your final report. And of course, you have to participate in the Zoom session that we're having today. So when you enter the manual lab simulation, you are going to have several aspects that you have to complete. So please use your time wisely, and if you have any questions on how to create a pendulum, you can contact me in Google Classroom. All right? So thank you guys for coming one more time, and goodbye. I will be seeing you next week.